Hello, I am Swati Verma, Assistant Professor, Chhattisgarh Swami Vivekanand Technical University, CSVTU, Bhilai. I welcome you all to the course on Industrial Automation and Drive. Today, we will begin with our 36th lecture with the title Interfacing the SCADA system with the PLC. But before learning how to interface the SCADA system with the PLC, we should have a quick introduction about the PLC and the SCADA. So first, what is a PLC? So PLC stands for the Programmable Logic Controller. It is an industrial computer which is used to control a specific process, machine system, or sometimes even an entire production line. PLC is an industrial computer without a mouse, keyboard or a monitor. As it is an industrial computer, a logical program is used to control the process and is prepared in the general computer. Then this program is then transferred to the PLC using a cable network. Then this transferred program is stored in the PLC memory. Now the logical program which is prepared can be designed or can be prepared by using a programmable logic network called as ladder logic, statement list or a functional block diagram. The program is prepared in such a way that the people with electrical or instrumentation background can easily understand the program and can analyze it. A programmable logic controller consists of various inputs and output terminals. It monitors the status of switches, sensors using the input terminals, and based on its status or the various threshold values, they will give the command to the output devices through the output terminals. Now we will discuss what is a SCADA. So SCADA is a short form of supervisory control in the data acquisition. As the name suggests, the SCADA mainly does three major operations. First, supervise the real-time data in the form of graphical presentation. Second, control the industrial processes locally or through the remote locations. Third is to acquire the real-time data as well as log data and to analyze it. The SCADA system is an important factor of the industrial organization and automation process as they help to monitor the process data as well as to control the processes and to easily detect any issue within the process and thus reducing the downtime or thus ensuring the safety of the personnel or the asset. Generally, the SCADA is completely a software package that is help or to use to monitor the entire area of the plant or industry. The basic architecture of the SCADA includes the programmable logical controllers PLC or the remote terminal units RTUs. Then the SCADA software processes and distribute and display the data on the monitor or the computer to better understand the operator about the field condition. As we know, the PLCs or RTUs are the microprocessor that communicate with the field devices such as valves, pumps, sensors, HMIs or the other end devices. These devices route all this collected data from the end devices to the SCADA computers. So now the question comes, how we are going to interface or to connect the PLC with the SCADA system. So to interface a PLC with the SCADA, we need to create a proper communication channel or a bus. The monitoring PC or the personal computer in which SCADA software is installed must be linked with this communication channel via its communication port. Now, how does a SCADA system work with a PLC? So basically the PLC serve as a local brain which operates the machinery and processes based on the real time data, executing the pre-programmed instructions to manage the minute to minute actions. In contrast, the SCADA system acts as an overseer, performing the continuous surveillance and providing a microscopic view of the entire operation through an intuitive graphical user interface. The intricacies of the SCADA PLC integration lies in a pyramid of ways. For instance, the PLC gathers the granular or the minute operational data such as temperature, pressure or the flow rate, which is then fed back to the or sent back to the SCADA system. Then the SCADA system, which is equipped with this vital information, allows the personal computer or the operators to monitor this operation across the vast distance and grant them the capacity to make the informed decision or to take the actions and the adjust instructions sent back to the PLCs. This feedback loop creates a harmonious interplay between the local control, which includes PLC, and the centralized supervision lies in the SCADA system. Furthermore, the SCADA system is designed to collate and analyze data over the extended periods, which empowers the stakeholders to discern the trends and improve the overall efficiency. Additionally, the SCADA alarming and the event logging functions enhance the overall safety of the industrial process by providing the timely alerts, allowing the swift response to the potential issues if occurs. This is crucial in scenarios where the immediate human intervention is necessary to prevent the operational disruptions or the safety hazards, thereby ensuring or to raise the robustness of the system and to make the system safe. Now the beauty of the SCADA system working with the PLCs lies in their complementary compatibilities. While the PLC executes the real-time control and the logical task reliably, the SCADA system offers a broader vantage point, ensuring the optimal performance, resource management and a strategic oversight. So, the unity of the SCADA expensive reach and the PLC's local precision enhance how the modern industry leverages technology to achieve the high levels of automation and control and to increase the efficiency of a process. Now, what are the benefits of integrating a SCADA system with the PLC? Integrating a SCADA, the supervisory control and data acquisition system, with the PLC with the programmable logical control is highly advantageous in the industrial automation, enhancing the control and monitoring and increasing the overall operational efficiency. So, here we will discuss some of the key benefits of integrating the SCADA with the PLC. First key benefit is the enhanced real-time monitoring and control. So, this integration of SCADA and PLC enables the real-time data acquisition from the various sensors and the devices connected to the PLC. This data is then processed and visualized by the SCADA system, providing operators with up-to-date insights into the status and the operation of the machinery and the process. This real-time feedback loops ensures a timely intervention and adjustment leading to the optimized process control. Second is the improved operational efficiency. By combining the strength of SCADA high level monitoring and PLC direct control capability, organization can automate complex tasks more efficiently. This automation reduces the manual intervention minimizes the downtime and leads to faster and the more consistent production processes. Next is the data analytics and the reporting. The SCADA system collect vast amount of data over a time from the PLCs, which can be analyzed to identify the trend, anomalies and the areas for further improvement. This data driven approach helps in predictive maintenance, energy management and the process optimization, which ultimately reduce the operational cost and improving the productivity of the system. Now, but implementing the SCADA with the PLC also has some challenges. First challenge is to compatibility with the legacy systems. Difficulty in ensuring the communication between the older PLC and the modern SCADA software. There is also potential need for the system architecture evaluation upgrades or the custom interfaces. Financial time and the resource investment are also required for addressing the compatibility issues. The second challenges of implementing the SCADA and the PLC is the complexity of planning, design and the testing, which requires the meticulous planning to ensure the seamless interoperability. It also includes the extensive design and testing phases to prevent the workflow disruptions. It also has the risk of data loss or the operational downtime during the integration process. The next challenge of implementing the SCADA and PLC is the cyber security, since it increases the complexity of securing the integrated SCADA PLC system. The balancing the robust security measure with maintaining the system functionality is also a concern. Also, the ongoing challenge for IT and the OT professionals to protect the critical infrastructure from the various attacks. Next major challenge is the operational disruptions. There is a potential for unintended disruptions to both new and the existing workflows. There is also need for the robust mitigation strategies to minimize the downtime and the data loss. Next main challenge is for the staff training and the continuous learning process. There is a need for the operators and the maintenance personnel which require the training on the integrated system. Also, the financial and the logistical challenges of organizing the continuous training sessions for the operators and the maintenance personnel is also needed. Also, there is a need for the ongoing education to keep up with the technological advancement and the best practices. So, here we have discussed about the challenges of PLC and the SCADA integration. Now, we will discuss about the communication protocols for PLC and the SCADA systems. In the world of industrial automation, PLC and the SCADA system plays a very crucial role in controlling and monitoring the various processes. But for these systems to function effectively and to collaborate easily, communication protocols are essential and a very vital part. So, now we will explore the significance of the communication protocols for PLC and the SCADA systems and discuss the process of choosing and implementing the right protocol. We will also address the benefits and challenges of using communication protocols in industrial automation, because whether you are a seasoned professional or just starting in the field of industrial automation, understanding these communication protocols can greatly enhance your knowledge and contribute to the success of your industrial project. The first thing, why the communication protocols important? Communication protocols are very essential in the world of industrial automation. They serve as the rules and the guidelines for data exchange between the various devices and also ensures that the information is transmitted accurately and efficiently. Without these communication protocols, the communication between the different components of a system would be unreliable and the system would not be so efficient. One of the key reasons why the communication protocols are important is the need for standardization. In the industrial automation, there are countless number of devices from different manufacturers. Each manufacturer has its own way of transmitting and receiving the data or using the different language. So, these communication protocols establish a common language that all devices can understand regardless of their origin or the type of manufacturer. Moreover, the communication protocols play a very important role in ensuring the safety of the industrial system. By using these protocols with encryption and authentication features, the organizations can protect their sensitive data and can prevent unauthorized access to their networks. Last, the communication protocols are very important for achieving the interoperability among various devices and systems. With the right protocols in place, different components can effectively communicate with each other, allowing for seamless and the continuous integration and the improved overall performance of the system. So, now next we will discuss the common communication protocols which are available for the PLC systems. When it comes to industrial automation, the PLC systems mainly rely on various communication protocols to ensure smooth and efficient operations. These protocols are essential for establishing the communication between the PLC and other devices in the system like the sensors, actuators and HMI panels. One of the most common communication protocol which are used in PLC system is the Modbus. This is the open source software protocol which is widely supported and allows for easy integration with a wide range of devices. The another popular protocol is Profibus, which is known for its high speed communication and robustness in industrial environment. The Ethernet IP is also frequently used in PLC systems due to its ability to support the real-time communication and seamless integration with other industrial networks. Additionally, the OPC UA protocol has gained now popularity for its secure and reliable communication capabilities, making it a preferred choice for many PLC applications. Overall, the selection of the communication protocols for the PLC system depends on the specific requirement of the application, including the types of device you are using in the application, the speed of the communication and also on the level of interoperability which is required or needed in the system. Now, we will discuss the typical communication protocols for the SCADA systems. The supervisory control and data acquisition called as SCADA are widely used in the industrial settings to monitor and control the various processes. One of the key component of the SCADA is its communication protocol, which defines the rules and conventions for exchanging the data between various devices and the systems. Like the PLC, there are several typical communication protocols commonly used in the SCADA, each having its own strength and the limitations. One of the most widely used communication protocol in a SCADA system is the Modbus, which is open standard protocol which is simple and easy to implement. It is often used for connecting the remote terminal unit, RTUs and the other field devices to the SCADA system. The another common protocol is DNP3, also called as Distributed Network Protocol, which is designed specifically for the utility industry and is known for its robustness and reliability in challenging environments. For SCADA systems that require high speed data transmission, the ISA 61850 protocol is often used, especially in the electrical substations and the power system. This protocol is mainly based on the Ethernet and provides high performance and real time data exchange capabilities. The another protocol that is gaining popularity in a SCADA system is the OPC and OLE for the process control, which is a set of standards for connecting the different devices and systems in industrial automation. Overall, the choice of the communication protocol for a PLC system depends upon the specific requirement, like for the based on the application, the factors like the data transmission speed, reliability and compatibility with the existing systems. So, by understanding the strength and the limitation of the different communication protocols, SCADA system designers can make informed decisions to ensure the optimal performance and the reliability of their systems. So, now choosing the right communication protocol for the integration. When it comes to industrial automation, the choosing the right communication protocol is very crucial for the efficiency and effectiveness of the system. The communication protocol are generally like we have discussed a set of rules that govern the exchange of data between the connected devices or systems. This communication protocols determine how will the data will be transmitted, received and acknowledged, which ensures the seamless communication within the automation system. There are several factors to consider while choosing the right communication protocol for the industrial automation. First and foremost factor which is to be considered is the compatibility. It is essential to ensure that the communication protocol which we are using or chosen should be compatible with the existing hardware and software in your automation system. This includes the compatibility with the PLC and the SCADA system as well as any other system or device or equipment that are part of the automation system. So, compatibility is the first and the most important key to consider while choosing the right communication protocol. Next important factor to consider while choosing the communication protocol is the reliability. The communication protocol must be reliable in the transmission of data, especially in the industrial environments where downtime or the data loss can have serious consequences. This means choosing a protocol that offers robust error checking and correction mechanism as well as redundancy options to ensure the data integrity and the continuity of operations. The next crucial factor to be considered is the scalability. Scalability is also a next key factor to consider when choosing a communication protocol. The industrial automation system are often designed to grow and expand over a time, and the communication protocol should be able to accommodate this scalability. By considering this factor such as the potential for adding the new devices or equipment to the network as well as the scalability or the ability to handle increase the volume of data as well as the system grows. Now implementing the communication protocols in PLC and SCADA system. So, the implementing the communication protocol is very crucial for ensuring the efficient and reliable industrial automation. In the context of PLC and SCADA system, the implementation of communication protocol plays a vital role, as we have discussed, in ensuring the interoperability and the integration of various devices and components within the industrial network. Furthermore, the implementation of communication protocols in PLC and SCADA involves configuring the network setting, establishing the data exchange mechanism, and ensuring the seamless connectivity between the various devices and components. This process also requires the in-depth technical knowledge and expertise to effectively set up and maintain the communication infrastructure, as well as to troubleshoot any potential issues that may arise during the operation. So, in conclusion, the implementation of communication protocol is a critical aspect of industrial automation, as it enables the seamless connectivity, data exchange and control functionality within the manufacturing and process environment. So, by selecting and choosing the proper communication protocol, industrial optimization configurations can optimize their automation system for improved performance, reliability and flexibility. Now, we will discuss the communication between the InTouch SCADA and the Allen Bradley PLC, which we have seen. This is the same PLC which we have used in the earlier lectures, or in which we have learned the timer and the programming languages and the counter programming languages. Here we will learn about the steps for establishing the communication process between the SCADA and the PLC. First step is to open the RS Logic software along with RS links and the emulator. Second step is to create a new project in the RS Logics and to establish a communication with an emulator. Step 3 is to open InTouch SCADA software. Step 4, as you can see in the below figure of RS Logics, I have created a small example having one input and one output device. The input device has an addressing of I:0/0, while the output device has an addressing of O:0/0. Here you can also see I have used a binary memory bit with the addressing B3:0/0, which we will use in SCADA to give a command. Next, in the step 5, open the RS links and choose an option DDE/OPC and choose the topic configuration, which you can see in the given diagram. So, now what is the DDE? Here the DDE stands for the dynamic data exchange. Here it is a protocol which is used as a communication or as a communication bridge between the PLC and the SCADA. Now, after choosing the topic configuration, in the step 6, we have to choose a new to proceed further. Next, in the step 7, after clicking new, you will get a new window. Here you have to create a new topic. Here, for the example, I have created communication, okay, and here you have to choose the communication protocol, okay. Then after choosing the communication protocol, click apply and then done to proceed. In the next step, now we will open the InTouch SCADA. We will create a new project, and here we will create a one input and one output device with one input button and one output button, as you can see in the figure. Then in the next step 9, we will double click. When you will double click on a button, the following window will appear, okay. Here we have clicked on the rectangle shape button. So, here at the top you can see the object type is a rectangle. After that, you have to choose discrete, which will open up a new window. When a new window will appear, give a name to the button. Here we have given a start name or start as the name to the rectangle button or the rectangle shape button. Here you can see the start, and after that you can choose any name which you can want to give to your button or the so you can to the input device, and you can click on the OK. Next, after this, in the next step, you have to choose the input output discrete in the type option. After choosing this, you have to click on the access name. Here you have to give the addressing. So you have to write the bit address in the item for input, which we have used in the programming software, which you can check in the step number 4 or in the previous step. Here in this next step, after clicking on the access name, it will open another window. Here you have to click on the add, as you can see in the given figure. Now in the next step, after clicking on the add button, this add access name will appear. This is very important step to establish the communication. Here in the access, you can give any name according to your choice. In the application name, you have to use RS Logics. In the topic name, I have used the communication. Remember the same topic name I have created in the step number 7 or in the earlier. Okay, so you have to write the same topic name here also. Here we have used the DDE as a communication protocol, and after filling all these parts, you have to click OK to proceed. In the next step, after configuration, you have to click on the save button and to close the pop-up. Next, in the step 5, for the output, you have to select fill color property. Okay, here in the fill color property, you have to choose the discrete and click OK. In the next step, in the step 16, you have to follow the same procedure for the output as we have done for the input button for the rectangle. Okay, so then after this, you can see here you have to choose the type, the IO discrete type, and in the access name, since we are using the stop button for the output, here we have feed the output addressing O:0/0. After this, you have to click on save and close the window. So after clicking the window, the communication has established. You can test the logic. So keep a window in the runtime and put your CPU in the run mode. As you can see in the figure, the window, the output gets energized if I give the command from the SCADA. Here you can see the output get energized, both the output color get green, and here in the ladder diagram, when we give the command from the SCADA, it get energized. So here we have learned, that's all for this lecture. So in this lecture, we have covered the interfacing SCADA system with the PLC. So in this lecture, we learned how a SCADA system works with the PLC. Also, we have discussed the benefits and challenges of implementing a SCADA PLC integration, and also learned an example or the steps for establishing the communication process between the InTouch SCADA and the Allen Bradley PLC. That's all for this class. In the next class, we will explore the SCADA programming. Thank you and happy learning.